Welcome to our series on linear algebra basic. In this first lesson, we will explore vectors, what they are, how they work, and why they are so important in math, physics, and beyond. A vector is simply an ordered list of numbers. In 2D, we write it like this: V equal to X, Y. In 3D, it looks like V equal to X, Y, Z. This is the 2D version of vectors, while this is the 3D version of vectors. The letters in each represent numbers. Each number tells us how far to move along an axis. Think of it as a set of instructions for movement. Let's take V, for example. Vector V equal to 2 and 3. This means that 2 units along the x-axis. So if here is my origin, is 0.0. So I'll move 2 units, which is 1, 2, along the x-axis, and 3 units along the y-axis. So origin, so I'll move 1, 2, 3. 3 units along the y-axis. If we draw this, it is an arrow pointing from the origin to 2 and to 3. Vectors are often represented as arrows because they show both magnitude, which is length, and direction. Let's look at how to find the magnitude and direction of a vector. Now, a vector is written in this form, for example, vector V with an arrow on top. This is called vector V. Now, a vector has a length or magnitude and direction. The magnitude of a vector is its length and is given as, for example, if we have vector V as S and Y, the magnitude of the vector is magnitude equal to the square root of x squared plus y squared. For a 3 vector, for example, V equal to x, y, z, the magnitude of the vector becomes magnitude V equal to the square root of x squared plus y squared plus z squared. So that is how we find the magnitude of a vector. To find the direction of the vector, the direction is the angle it makes with the axis. Together, magnitude and direction make vectors powerful tools for describing motion, forces, and more. To find the direction of the vector, which is the angle, the direction is theta equal to tan inverse of x over y. Let's look at a question. Suppose we have the vector V equal to 3 and 4. What is its magnitude and what is its direction? To find the magnitude of the vector is magnitude V equal to the square root of 3 squared plus 4 squared. That gives us the square root of 3 squared is 9 plus 4 squared is 16. So square root of 9 plus 16 is 25, and The square root of 25 is 5. So therefore, our magnitude is 5. To find the angle of this vector or the direction, what we do is to use the formula, which is theta equal to tan inverse of y over x. Remember, the first number is x, while the second number is y. So therefore, we have tan inverse of 4 over 3. When you put that in your calculator, our theta is equal to 53.13 degrees. So the vector 3 and 4 has a length of 5 units and points out about 53 above the x-axis. Real-life applications. So vectors are not just abstract maths. They describe the velocity of a car, speed plus direction. They describe force applied to an object, and they also described the position in computer graphics and video games. So whenever something has both size and direction, you are dealing with vectors. In conclusion, vectors are more than just numbers. They are arrows that tell us how to move in space. In our next lesson, we will see how vectors interact with matrices to create transformations. Stay tuned.